Hello students, welcome back. We continue our discussion on the chapter midpoint theorem. Today we are going to start with theorem on intercept. In the last two classes we learned about the midpoint theorem, converse of midpoint theorem, and in this part I am going to explain you theorem on intercept. So let us begin. Statement of the theorem is if a transversal makes equal intercept on three or more parallel lines, then any other line cutting them also make equal intercept. Now let us explain this statement. For example, here L parallel to M parallel to N is given to you, and a transversal P cuts the line LMN at the point A, B and C such that AB equals to BC. Now, if any other line, suppose Q, cuts them at D, E, F, so we need to show that DE is equal to EF. To prove this theorem, we need to draw a line through E which is parallel to the line P. That means this line R is our construction which is parallel to the line P. Clear? Now, first ABEG is a parallelogram. ABEG is a parallelogram as AG is parallel to BE and AB is parallel to GE by construction. So if it is a parallelogram, so we can say that AB equals to GE. Opposite sides of a parallelogram are equal, so we can say that AB equals to GE. Similarly, we can say that BCHE is a parallelogram, and if it is a parallelogram, so we can say that GE equals to EH and BC equals to EH. So now we going to prove these two triangles are congruent to each other. Now in these two triangles, these two angles are equal. They are vertically opposite angle. These two angles are equal as these two lines are parallel to each other and this is transversal. So they are alternate interior angle. And GE is equal to EH. We have just proved that. So these two triangles are congruent to each other. Therefore, by CPCT, we can say that DE is equal to EF. Now, let us solve one problem. Show that the quadrilateral formed by joining the midpoint of the adjacent sides of a square is also a square. Here ABCD is a square where EFGH are the midpoint of AB, BC, CD and DA. We need to join EF, FG, GH and HE. So we need to prove that EFGH is a square. For construction, we join the two diagonals, that is AC and BD. Now look at the triangle ADC. In the triangle ADC, G and H are the midpoints of the side AD and DC respectively. So we can say that GH is parallel to AC and GH is half of AC. In triangle ABC, E and F are the midpoint of AB and BC respectively. So we can say that using the midpoint theorem, EF is parallel to AC and EF is half of AC. So now using these two conditions, we can say that EF is parallel to GH. If you look at this, GH is parallel to AC and EF is parallel to AC. So these two lines are parallel to each other, and EF is equal to GH equals to half of AC. Now if you take the other part of the triangle, so similarly we can prove that HE is parallel to GF and HE equals to GF equals to half of BD. Now, since ABCD is a square, so we can say that diagonals of a square are equal to each other. So therefore, AC equals to BD. If AC and BD are equals to each other, that means these four sides are equals to each other. That means EFGH is a parallelogram. Now once it becomes a parallelogram, the next task is we need to prove that it is a square. Now to prove this, we consider the triangle GOH and triangle GOF. We consider these two triangles. Here OH is equal to OF. Diagonals of a parallelogram bisect each other. OG equals to OG common and GH equals to GF. Since EFGH is a parallelogram, so we can say that these two triangles are congruent to each other by side axiom. Now if these two angles are equal, so we can say that GOF equals to GOH by CPCT. Now sum of these two angles is equal to 180 degree. This is a linear pair, so we can say that GOH equals to 90 degree. Now in a parallelogram, if the diagonal intersect each other at 90 degree, so that will become a square. So diagonals of a parallelogram EFGH bisect and perpendicular to each other. Therefore we can say that EFGH is a square.